Right then, chaps, let's have a look at this question. So this is about hydrolysis of esters. So an ester can be hydrolyzed by heating it with sodium hydroxide. Give the equation. Well, because it doesn't specify, you can sort of just do however you like. When it comes to esters, I always find it easier to draw out the displayed rather than the structural. You know, your mileage may vary, but I think that's easiest. So there's the sodium hydroxide, and so we're going to get the salt, aren't we? Because you've got the sodium knocking around in the solution. You're not going to get the carboxylic acid. You're going to get the carboxylate salt and plus your alcohol back. So remember, when you hydrolyze an ester, you get back what you put in. So you get the alcohol and the carboxylic acid again. Right, the next one, you can read all through that. I'm sure you've read through it, but it's very straightforward. I hope you'll find you just have to rearrange the equation. So we're trying to find the MR, right? So if you rearrange that, it becomes mass times 1000 divided by V2 minus V1. So just got to rearrange it and put your figures in. So it's 1.76 times 1000 over 50 minus 30. So it gives you MR of 88. Okay, this is all about an insect repellent. Yeah, quite, there's quite a lot going on here. You have to identify reagent C that can be used to convert 3-methyl benzoic acid, which is this, to 3-methyl benzoyl chloride, which is that. So what are we going to put in there? Well, this is an acid chloride. Remember, if you replace the OH group with the Cl, that's an acid chloride. So to get the acid chloride, there's 3 things you could use, possibly. PCl3, PCl5, or sulfur dichloride oxide, SoCl2. And this one would be the preferred choice because it gives you your acid chloride, and it also gives you 2 other products which are gaseous, so there's no separation required. Right, DEET is colourless liquid in white light. So why is it colourless in white light? Because it doesn't absorb in the visible region. Bit of physics coming at you there. So all wavelengths are transmitted. Okay, this next one is you just have to do a bit of fiddling around. So the mass spectrum of DEET shows a molecular ion at mass to charge ratio 191. So what that means is this whole thing has a mass of 191. Okay, so suggest a formula for the fragment that is lost. So there's also a peak at 91. So you have to try and find a fragment that weighs 91. And if you just take off all that, that has a mass of, that has a mass of 100. Okay, so if the whole thing weighs 191 and there was a peak at 91, okay, so that means there's the fragment that is lost must weigh 100 or have an MR of 100. So that that fragment there has an MR of 100. So that is the fragment that's coming off. Okay, and here's an alternative insect repellent, dimethylbenzene 1,2-dicarboxylate. And that's made by the oxidation of that. So state the oxidizing agent used. Okay, so what we're trying to do to create this, we are starting off with 1,2-dimethylbenzene. Okay, so we need to oxidize methyl side chains, okay, to turn it into that. So if you oxidize, if you didn't get this, go back, look at your notes. There's a little section we did about oxidizing alkyl side chains, and you use KMNO4, and we use alkaline hydrolysis. Okay, Explain why it's necessary to acidify the product of this oxidation. It's because if you use KMnO4 as your oxidizing agent, you will get the potassium. There's your potassium. You will get the potassium salt first. So you'll have to acidify that to protonate the oxygen. Okay, displace the potassium back into solution. Okay, so just there's a synthesis, a few steps of synthesis, or a couple of steps, and we're just producing a different insect repellent called BA. Draw the Zwitter ion structure of 2-amino-benzoic acid. Okay, well that's your 2-amino-benzoic acid. So remember Zwitter ion, this hydrogen is gonna go over there. So you should have something that looks like this. NH3, that's your positive charge, and COO, there's your negative. Explain why compound T, this one, why is that initially produced? Because if you've got HCl catalyst, you've got lots of H plus knocking around, and the NH2 group can accept a proton. So there we are. So you've got the NH3 plus, and then if you've got a positive charge, because you've got the Cl minus in there as well, that's where that comes from. So it's essentially due to the basic nature of this NH2 group. So question 8 now, we're talking about producing something called chloroethanoic acid. By reacting ethanoic acid with chlorine, so it's a radical reaction. You might remember that from year 12, I hope you do. Suggest the formula of the new radical formed from the acid during this reaction. Okay, so because it's a radical, I mean this is going to become radicalized. You have two of those, and they are what's going to attack this molecule here. Okay, now the radical that will be produced will look like this: CH2, COO, H. There you go. It's going to take one of these hydrogens off there. Okay, part 2. In an experiment, 89 grams of ethanoic acid. So you've got 89 grams of this. They give you the MR, which is nice. So calculate the increase in mass. Okay, so, well, firstly, if we've got the mass and the MR, you can say number of moles is 89 over 60, which is 1.483, and we're looking at the chloroethanoic acid. That's the only product. They're in a 1-to-1 ratio, right? It's 1-to-1 ratio. So you'll also have you'll also have the same number of moles. So 1.483 moles of this. So the mass of that will be number of moles times MR. So it's 1.483 times 94.5. Right, let's have a quick. So it's 140.1 grams. That's not the final answer. That's how much of that you're going to get. But it asks for the increase, doesn't it? So you start off with 89, you're going to end up with 140.1. So the difference is 51.1. Okay then, so this next step. So in the experiment described in part 1 here, 89 grams gave 49.2 grams of aminoethanoic acid. Calculate the percentage yield. Okay then, so well, we know the number of moles, so the mass is going to be 1.483. We know the number of moles that will be produced because it's 1-to-1-to-1. So this number of moles times 75, which is the MR of aminoethanoic acid. So that gives you 111.3 grams. So that's your theoretical yield. So your actual yield was 49.2. So it's 49.2 divided by 111.3 times 100. So percentage yields would be 44.3%. Okay, aminoethanoic acid is isolated from the solution of the products by adding methanol, and the acid is precipitated as a white solid. So suggest why aminoethanoic acid is insoluble in methanol. Okay, so firstly, if you look at aminoethanoic acid, it's gonna this is aminoethanoic acid. See, OH, so hydrogen, NH2. Okay, so that's aminoethanoic acid, and based on what we've just been discussing, you might notice that we might guess that this could possibly form a Zwitter ion. Okay, so that's going to be positive, and that's going to be a negative end. Okay, so the first thing I would say, Zwitter ion are formed. So we've got this ionic, this ionic nature, and because methanol is a covalent solvent, ionic compounds won't dissolve generally in a covalent solvent. Will not dissolve in covalent solvent. Remember the old expression, like dissolves like? So if you're trying to dissolve something ionic, you'll need an ionic solution. The same with something covalent, you'll need a covalent solution. Right, so part B, explain why an aqueous solution of aminoethanoic acid does not affect the plane of polarized light. So because if you look at the carbons, there's no chiral center. Right, we haven't done dipeptides yet, so that's in the next module, so we're just going to leave that one, okay? I'll make a note to tell you not to do that one. Okay, part D. Aminoethanoic acid reacts with nitric acid, produce nitrogen gas. Nitric 3 acid, that is. Calculate the minimum volume of nitrogen gas. So we're calculating the volume of gas. We've got the pressure, we've got the number of moles. Right, so it's our ideal gas. So PV equals nRT. So N number of moles is, we're given it in the question, 0.3 times 8.31 times, well, it's 100 degrees, but we have to put it in kelvins, don't we? So just add 273, so it's 373, and that's all. I've rearranged this in my head as V equals nRT over P. That's what I've done. We're trying to find the volume, aren't we? So you divide that all by P, which is 98 kilopascals. Remember, this has to go in as pascals, just 98,000. So, give me a second, 0.3 times 91 times 373. So, final answer, we have to give it in decimeters, so convert that and you get 9.49 cubic decimeters. Okay, part E, prepared by reacting chlorine hydroxide. Whenever they're asking about why do you need to acidify the solution, it's because 99 times out of 100, it's because you'll be producing some sort of salt. Okay, so the salt is produced first. So you'll need to protonate. Get rid of the salt and protonate the oxygen with hydrogen. So you need to acidify the solution. Okay, so there's the answers. They were fairly tough, I thought. So just please work your way through them. checking off any marks you didn't get. Watch this video through and just make sure you green pen your work and make sure you understand. Don't leave anything, no stone unturned. Okay, don't think, oh, I'll get that next time. Just make sure you get it today. Okay. Okay. Speak to you later.